What's up, y'all? Algebra 1, 4.3 exercises right here. So this is not in order. I'm starting on problem number 11. So we're supposed to create a line that goes through the point 18, 2 and is parallel to this line, 3y minus x equals negative 12. And so I use point slope form, and I plug in x1, y1 into these two places right here. See my 18 and my 2. And because it has to be parallel to this line, I need to figure out what the slope of this line is by putting it into slope-intercept form. And I do that by solving for y. So I'm taking this equation that I have to be parallel to. I solve for y, get it into y equals mx plus b form, find that the slope is 1/3. And I use that in my point slope form, and I plug 1/3 in right there for the slope. So then after I have this in point slope form, my answer many times is asked for in slope intercept form. So I distribute the 1/3, and I get 1/3 times x is 1/3 x, 1/3 times negative 18 is negative 6. And then I add 2 to both sides, and I get my answer. Now going to number 9. This is another problem of the same type where we're trying to find the equation of a line that goes through this point and is parallel to this line. And this one's a little easier because it's already in slope-intercept form, and I can see the slope is 2. So I'm going to use that slope and point slope form. So I'm plugging in my parallel slope because parallel lines have the same slope. 2 is parallel to a slope of 2. And I have negative 1 is my x1 and 3 is my y1. And so I've plugged those in. Y minus 3 equals 2 times x plus 1 because my x1 is negative 1. And so when I go x minus negative 1, I have to put x plus 1. And then I distribute the 2 and add 3 to both sides to get my answer in slope-intercept form where y equals 2x plus 5. Number 15. This is where I have to compare the slopes of lines represented by points that go through the lines. So line A has 2 points that go through, line A goes through these 2 points, and line B goes through those 2 points, and so on. And so I'm going to use the slope formula to calculate the slope for each of the lines, my y2 minus y1 over x2 minus x1. And I calculate that 3 minus 1 over 0 minus negative 2. So I've got my slope simplified here, and I do that again for line B that goes through these 2 points and line C. And so I look at the slopes when I'm done. 1, 3 over 2, and negative 2 over 3. Now I need some help here because the version of this problem that I looked at online, it says that none of these slopes are the same, or maybe it's in the parallel section. So anyway, none of the slopes are the same, so none of these lines are parallel. But if you do observe that line B's slope and line C's slope, they compare and they are perpendicular. I don't know if the question asks that, but none of the slopes are parallel, but line B and line C are perpendicular because they have opposite reciprocal slopes. 3 over 2 is the flip and the opposite of negative 2 over 3. All right, moving on to number 17. Number 17, we're comparing the slopes of all of these lines, and we're going to find out if anything is parallel or perpendicular. So here are the 3 equations, and I write them side by side so that I can solve for y and get all of them in y equals mx plus b form to compare their slopes. So this first equation, I solve for y, and I get y equals 4 over 3x minus 2/3. And the second equation already is solved for y, and I can see the slope. And the third equation, I solve for y, and y equals mx plus b, the slope is negative 3 over 4. So I'm comparing 4 over 3 with 4 over 3 with negative 3 over 4. So my conclusion is that A and B have the same slope, so they're parallel. Sorry, this is kind of messy. I have this big parallel symbol right here, which is two long lines like that. Anyway, A and B have the same slope, and so those two lines are parallel. A is perpendicular to C, and B is also perpendicular to C. So we have opposite reciprocal slopes, and sometimes in the book it says negative reciprocal slopes. So opposite and negative are synonymous. Number 3. All right, so number 3 has 3 lines that I have to look at on a graph and count the slopes. So I count the rise over the run for all 3 of them, and they are all, oh no, look at this, line A and line B have the same slope, so lines A and B are parallel. And number 5, it's similar to one that we did before, where we have to find the slope of each line that goes through 2 points that we're given. So we look at the 2 points, use our slope formula, we do some subtracting and simplifying, and then we get that the slope for line A is 1, the slope for line B is 2, and the slope for line C is 1. And so lines A and C are parallel because they have the same slope. Yeah. All right, number 7. Number 7 is where we've got 3 lines, and we need to solve each of them for y and get them into y equals mx plus b, and we need to look at all of the slopes. And so the slope is in this position, and so the slope of line A is negative 1/4, the slope of line B is negative 1/2, and the slope of line C is negative 3 over 2. So they're all different, so no lines are parallel. I don't see any opposite reciprocals either, so none of them are perpendicular either. We already looked at 9 and 11, so now we're looking at number 13. Okay, number 13 has 3 lines on a graph, and so you count the rise over the run, and I counted line A's slope as 3 over 2, line B's slope is 2 over negative 4, and so that simplifies to negative 1/2, and line C's slope is rise 5, run 3. And they're all different, so none of the lines are parallel because there are no matching slopes, and none of the lines are perpendicular because none of the slopes are opposite reciprocal. Okay, number 19. Number 19 is asking you to write a line that goes through the point 7, 10 and is perpendicular to the line y equals 1/2 x minus 9. So in order to find the perpendicular slope that we need for our new line, we need to see that the slope of this line is 1/2, and the perpendicular slope to 1/2 is where you flip it over and make it the opposite. So we do that, negative 2. 1 over 2 flips over to be 2 over 1. The opposite of a positive is a negative. And so this simplifies to negative 2, which is why I put that in for the slope right here. And I have my x1 and y1 values from the point that you're given. And that goes in, 7 goes there and 10 goes there. And then you distribute the negative 2 and add 10 to both sides to get the equation of the line in slope-intercept form, which is where you enter it. Number 21. Here we have to find the line that goes through negative 3, 3. And it has to be perpendicular to this line right here. In order to find the slope that is perpendicular to this line, we need to be able to see the slope in slope-intercept form. So I have to divide through by 2 to get my slope is 4. Y equals mx plus b. And so the slope of this line that's perpendicular to my new line, 4, perpendicular slope negative 1/4. So I take 4, which is 4 over 1, flip it over and make it negative. And I plug that into point slope form. and I plug in my x1, y1 into point slope form here, distribute the negative 1/4, and then add 3 to both sides, and you can see my work there if you need it. Thanks, you guys.